If one is lucky enough to witness those beautiful, shimmering, phenomenal light shows that illuminate the sky with its shades of blue, green, or red, they would be intrigued and entranced by its beauty. They would have witnessed and seen what is called an aurora. Auroras are shimmering lights that seem to be displayed in the sky near the polar regions, that is, the north and south poles of the Earth. This phenomenon is named after the Roman goddess of dawn, Aurora. The auroras are most commonly visible near the poles. Near the North Pole, they are called the aurora borealis, or northern lights. Near the South Pole, they are called the aurora australis, or southern lights. It appears as colorful clouds, streamers, arcs, bands, or streaks that dance and flicker in the atmosphere, and is caused by the collision of charged particles. Both the northern and southern lights have the same source and the same influence. An aurora is simply caused by the collision of the electrons that come from the solar winds from the sun and the gaseous particles that cover our Earth's atmosphere. As we all know, the sun is the main source of energy. This source of energy is created deep inside the core of the sun, where the temperature is over 14 billion degrees Celsius. At such high temperatures, gas molecules can frequently collide, and many thermonuclear reactions occur. Some of the byproducts that result from these reactions are the emission of charged particles in the form of plasma. When the sun rotates, free electrons and protons leave the sun's atmosphere and escape through holes in the magnetic field, and they make up the solar wind. The solar wind is carried away from the sun at speeds that range from 300 to 1,000 kilometers per second, that is, about 1,000,000 miles per hour. Around 40 hours later, the solar wind reaches the Earth's atmosphere. When the solar wind reaches our planet, the charged particles are largely deflected by the Earth's magnetic field, which is also known as the magnetosphere. The magnetic fields couple together and create a funnel where the gas streams down along the magnetic lines towards the poles. When the electrons have been deposited near the poles, they interact with the elements in the atmosphere. The auroras are a result of billions of these energy transfers in the form of light happening at the same time. As the electrons enter the Earth's upper atmosphere, they will encounter atoms of oxygen and nitrogen at altitudes from 20 to 200 miles above the Earth's surface. The color of the aurora depends on which atom is struck and the altitude of the meeting. Each creates a different shade of green, red, or blue.